So, good morning, good morning, good morning. I'd like to introduce assignment 4 for you today. Assignment 4 is, in theory, forced fun, registered trademark. So, let me explain sort of the metagame before we get into this, right? So, presumably, all of you are doing this college diploma because you want to work in this field, right? You want to get jobs. Good. If anybody was here and didn't want a job in this line of work, I would say there are lots of other programs at the college. You should probably consider another line of work if this one doesn't appeal to you, right? Like, you know. But, you know, as much as I'm down on software a lot, there are things to recommend this field. It's kind of fun solving little puzzles, right? So, what do you need to secure employment, right? Or maybe just what do you need to secure a co-op? A fantastic idea is to have a software developer's portfolio, particularly if you are in any way interested in web development as a discipline. It's a good thing to have generally. Any software developer these days is expected to know some web development, enough to put together a decent web page, right? So, making a portfolio website should be a goal. So what does a portfolio website is bad if it's just an HTML version of your resume, right? Part of what you're trying to do is attract attention by demonstrating your programming skills. And one of the ways that you do that is with projects, right? There should be a section on any good portfolio website listing the projects which you have done, engaged in recent years. Something demonstrating your skills. If you do this one right, this is a portfolio project, right? If you kind of schlep around with this one, you know, put in the sort of minimum requirements to get the grade, I will not recommend it as a portfolio piece. When I grade these, I will tell you whether I think it would make a good portfolio piece or not. Yes?
Are we able to add it to a public portfolio since it's an assignment?
Yeah. For the, the reason that this one is of this nature, I wouldn't recommend that for assignment 2, right? Assignment 2 is a bit too prescribed, right? You're just kind of solving math problems, and, you know, solving math problems is an important thing to be able to do, but it doesn't really demonstrate your ability to put something complicated together with a lot of moving pieces, right? This one is a creative assignment. You have a great deal of creative flexibility on this one. As such, it's entirely probable, I would hope, I would expect that no two assignments that I'm going to receive for this one are alike, right? Although, you know, sometimes it's obvious people kind of talked about ideas and people went with similar ideas, but even when that happens, if the development is independent, the end product ends up sufficiently different that it's like, oh, you both tried to do a version of this, but they're very different versions in the end, right? So, yes. So what am I even talking about? Assignment 4 is make a video game. We've been studying the SVG graphics system for, last week at least. we should be conversant in working with basic shapes. Much of the stuff we already know from JavaScript and DOM manipulation can also be applied to SVG. So, we write an SVG view of the game, we give it interactivity in JavaScript. These are the broad strokes of this assignment. So, again, if you put some effort into this one, give me a nice, polished product, there's absolutely no reason why that can't be a portfolio piece for you, right? Video games tend to make pretty good portfolio pieces. It's kind of, because they've got visuals, it's very easy and intuitive for people to understand, oh, this is a fairly complicated program actually. Even people who are not necessarily, programmers themselves, right? Because you're not interested just in impressing a technical manager, you also have to get past HR, right? So, does all of this make sense? Good. Sufficiently motivated? All right. So, some pieces of advice. Video games can be very complicated, right? I made a pinball game once that I released on Steam and it took me about a year. Well, like a year and a half. Right? And I was working with something that had a physics engine. Right? Not like a year of constant work. It was like, a year of an hour a night kind of territory. In most video game projects, if you're doing solo development, the artwork takes 2/3 of the time and the programming takes 1/3 of the time. So in this case, we're not really expecting you to do any artwork. You can just use basic shapes in SVG, that's sufficient. So that should, that knocks knocks 2/3 of the time that would otherwise be off the top. You're free and welcome to use images that you find on the internet, all of those sorts of things. There's a short list of suggested projects here. Suggested projects. They're very loose suggestions, and these are usually only used by people who, don't really have anywhere else to go creatively, shall we say. You're by no means required to do any of these. Coin flipping games, dice rolling games, memory matching puzzles, perhaps even typing or HTML tutorials. But it's very, very important to constrain the size of the game, right? Something like, if you're interested in kind of re-implementing a classic game, something at the kind of Atari level would be good. There are Atari games that I even wouldn't recommend doing. You guys are familiar with the Atari? Yeah? We're talking games like, Space Invaders, Asteroids, Centipede, right? There's a large collection of these. Pong is actually more difficult than you might think it is, because it involves collision. If I were you, only go after something with a real physics system, if you're really feeling up for a challenge. Something like Pac-Man is a lot more complicated than you might think it is, right? Are you guys kind of getting the flavor? Yeah? Now, maybe next week I'll bring the, on my laptop I have like a list, maybe I'll bring it at break, a list of like some impressive projects from the recent past. But the one that kind of stands out to me more so than any other one, this one guy made Wolfenstein like crossed with Slender Man. So like it's a three-dimensional maze where you're like panning around and the maze is moving around you. And the way that the maze is rendered is it uses like vertical rectangles, and it simply like increases or decreases the height of the rectangle proportionally to like how far away that segment of wall is. Highly, highly impressive. Now that one was a portfolio piece because it was running in bloody JavaScript. It was amazing. And you could do, like, there were all kinds of interesting interface, like things in the interface, like you could vary the width of the rendering rectangles, and it's like, oh yeah, so that's how the renderer works, you know? Very good demonstration piece. But yeah, so that's like right at the top end. There's a YouTube video linked here, which kind of demonstrates something that's a bit more typical. There's Steve. That's Steve, by the way. If anybody hasn't met Steve, that's Steve. So, I believe in the year that he did this, like, runner games were kind of like the thing he said, that's a good example of something to do. You know, a runner game isn't a bad example of something to do. Here's another example, which is kind of like, you know, the physics are a bit more janky, but you can tell, like, this one's a bit more obvious that it's like, it's literally just SVG things, you know? Here's another one. You know? Your always present Flappy Bird clone. Yeah. I asked the other class if, like, the game Flappy Bird has, like, passed outside of cultural memory at this point. Does anybody know what Flappy Bird is? Yeah. Anybody not know what Flappy Bird is? Interesting. Yeah, I had to explain the concept of Flappy Bird. But, so that's kind of like where we are, right? There are more examples in this video, but I'm going to move on. So you guys kind of get the idea? I will say a couple of things. Number one, don't get the bloody AI to generate your project, obviously. Number two, please don't follow an online tutorial, alright? It's still plagiarism even if you did all of the keystrokes that you copied from someone else. Like, when we say copy-pasted from the internet, we don't care if you got the computer to copy-paste it or you yourself did it through your eyes and your fingers on a keyboard. It's still copying, right? So, I'm not impressed by following an internet tutorial. It needs to have come from your brain. Alright? And anybody who submits Snake instantly gets an academic integrity charge. Just flat, you get a charge for Snake. Don't give me Snake, yes.
Are top-down platformers fine?
Top-down platformers are good. Top-down platformer.
Or not platformer, but like just top-down,
Like-
exploration.
Like Zelda style?
Sure.
Like the old Zelda games? Yes. Good. Those types are actually quite a bit easier than a side-scrolling platformer because they tend to involve less physics. You do still have to worry about collision with walls though. But yeah, entirely possible. Anybody else have any ideas for a project that they'd like to do? If they'd like me to tell them if that's a good idea or how much work it is? Yes?
How about Tetris?
Tetris is not bad. Tetris is kind of close to like a problem that occurs many times on the internet. So if you're going to do Tetris, this is my recommendation. Either do some Tetris variant, of which there are multitudes, right? Or come up with your own Tetris variant, right? One of my favorite Tetris variants is Kirby's Star Stacker. Have you ever seen this game? Let's see here. This is going to be an ad, I know it. Oh, surprising. Alright. So basically, the object of this game is you have to sandwich, you create a line by like sandwiching things between two like symbols, right? Which are like Kirby characters. And you have to collect X number of stars to clear the level. And the whole, like, you're trying to make as many combos as possible. But, yeah, that's a good one. Like, there's a million different takes on Tetris, right? Have you guys ever seen Hatris?
No.
It's Tetris with hats. There it is. Hatris. You're just stacking hats. Although it's a little more complicated than it seems because like you have to stack 5 hats to clear them from the board. But like, you know, when there are only 3 types of hats, that's not, and like you have to like put it on the taller stack first and then the lower stack. But like once you get to like the higher levels, it gets, you know, quite complicated, right? But yeah. Yeah, like, so maybe not Tetris itself, but something like there's literally infinity numbers of variations of Tetris, so go pick one. Yeah?
We need to kind of like provide for the user some type of instruction of how to play it, or we intend the user will figure it out?
I would very much appreciate if you provided the user, myself, just a small, it doesn't have to be complicated, just a couple of instructions on how to play, because like, I have to play your game, and I have to grade your game based on like, what's interactive in it. So like, if one of the events that I'm trying to grade is like a right-click event on like a background element, or something that's not obvious, I'm probably gonna miss it, right? I do like quickly check the code to make sure I haven't missed anything, but like, just instructions please, yes. Just some instructions would be much appreciated. And you're embedding this thing in a web page, so it's easy enough to write a few lines in a paragraph about it. Anybody else have any projects that they'd like to run past me? Yeah.
What about like a typing game where essentially just like a word will appear and it's like kind of like any game where you try to improve your typing, like one of those games.
Like Typing of the Dead?
Yeah.
Yeah, go for it. Yes. Anything else? Anybody else? Got any ideas?
How about the Google dinosaur game?
Well, that's like the runner game, so that's like definitely there. You know what? I have to tell you this. Last year, one guy made such a good clone of the Chrome Dino jumping game that like I couldn't tell it apart from the real one, and I thought he had stolen it. So I hauled him into the office and I said, "This is basically just the Chrome Dino game." And he's like, "Yeah, but I made all the graphics myself. Here are the files." And it's like, "Oh, yeah, okay, well, you can go. You're free to go, but understand that I thought you cheated." So you did very, very well. It was one of those situations where, like, you know, I thought they cheated, so they did extremely well, you know? It was extremely good, like, it was exactly the Dino Jump game from Chrome. So yeah, that's another one you can definitely do. They don't have to be that complicated, right? Anybody else with an idea? If you have any ideas later on and you want to send them to me by email, I would happily tell you what I think you can do to sort of either jazz them up, differentiate them from what's existing, or whether it's a terrible idea and you shouldn't do it. Because there are a lot of terrible ideas out there, you know? So, so let's talk about what the minimum requirements of the assignment are. These are what the assignment is graded according to. So, you know, but let's just, yes?
It says 2 types of mouse events, but can we add key strokes as well? Like
So,
arrow keys?
I normally loosen this one up a little bit. If you want to do 2 mouse events, if you want to do 1 mouse, 1 keyboard event, or if you want to do 2 keyboard events, I'm happy with any of that. You can also do more than that. The main thing is there need to be at least 2 different ways of interacting with the game. Make sense? Yeah. And it has to be related to, like, user input, right? And good grief, if you're going to put scroll wheel in there, tell me in the instructions, because I'm probably going to not check that scroll wheel does anything. Okay. So, you must meaningfully make use of SVG graphics. So you're not allowed to make the game using divs, right? If you've made the game using divs, it's probably not meeting many of the requirements anyways. A lot of, like, there's kind of one famous example where, like, I nailed someone for academic integrity because they used a tutorial to make a Flappy Bird clone using divs and not SVG. Like, getting a certain, like, giving me a complicated project using the wrong thing at that fundamental a level kind of means to me that you didn't read the document, you pulled the tutorial out of the internet, and you just did that and you've submitted it, right? Most of the time that's the case. So please use SVG to do your thing. The SVG elements must be interactive, using at least 2 types of JavaScript mouse events, or a mouse and a keyboard event, or 2 keyboard events, any of those types of combinations. And you don't have to use, you know, just 2, you can do more than that, right? If you're doing like a Zelda-like walk around, you know, you're kind of already there because you've got up, down, left, and right. These elements must have the ability to be removed. They must disappear from the screen and be removed from memory. So today, once I stop talking about this assignment, the object of today's lesson is object creation and destruction from JavaScript. We'll cover that in both SVG and in regular web pages. So basically, I'm going to be teaching you today how to do that. But basically, if we're taking runner games as our example, when the wall you're jumping over goes off the screen, delete it. That's a requirement. Okay? If you're doing a Space Invaders clone, when your bullet hits an alien, both the bullet and the alien should disappear. Right? These elements must be creatable by some mechanism. Suggestions include an add button or a timer that spawns them in. After creation, they should appear on the screen. So, not only do you have walls disappearing behind your jumping sheep, you have walls appearing on the other side and traveling. And it's not just like you've laid out, 50 walls that have been hard-coded in, and you're just moving them down so the game ends after 50 walls. You have to actually write the code to spawn them in randomly. Okay? Sounds good? You may have an initial layout of hard-coded elements if you desire, but all other adding and removing of elements must be dynamic using JavaScript. And in fact, even your initial layout, it might be easier and faster to do that in JavaScript as well, as an initialization routine. Style your SVG elements using CSS in addition to basic XML parameters. I don't actually care if you do that. There's a thing in here about making it mobile friendly. I also don't care about that one. So don't worry about responsive design for this one. Don't worry about CSS. Put your energy, put your points, spend your mana on making a good game that's impressive, that people will look at and think, oh, this person is a programmer. So, animate at least one SVG element using JavaScript. The animation must be obvious and noticeable. Do not fill this requirement with CSS animation, and do not use animated GIFs. Animated GIFs do not count. Let's review the definition of animation. Right? Animation is a series of slightly changed pictures producing the illusion of movement. Right? So, the question that then becomes, what do we mean by movement? The most ready-to-hand definition of movement is, of course, physical translation, right? If you have a circle occurring at this location and over time it moves to that location, that is simulated movement, right? However, it's not the only form of simulated movement. Expansion or contraction also counts as movement. Changing colors counts as movement. Basically, the modification of any visual property over time counts as movement. Does that make sense? Our example, our CSS animation example, where we oscillated through the colors of the rainbow for the text, that would also count as movement according to this definition. Okay? Sound good? Normally, you'll only run into that like the only time I ever seem to need to deduct marks for that particular one is when people have done like the absolute bog standard coin flipping game or dice rolling game. Like, if your game is like, click a button and instantaneously, you know, a 5 appears, click a button and instantaneously a 3 appears, you're failing on a number of requirements of this assignment. Number one, if you're instantly popping from one state to another, that's not animation. Number two, if you have a button, right, like an HTML button that says roll the dice, and that's how you interact with the SVG, you've not met the requirement of binding click events to SVG elements. Right? So that loses you points in that category as well. Does that make sense? And especially don't make this a div. So there is an additional requirement that you take some form of HTML input element and you hook that up to some, you hook that up in some way to the SVG. So there's a great deal of latitude on what is acceptable here. Typical examples include maybe you have a color picker, there's a color picker input element, right? You can use a color picker to select the color of the player character or something like that. Enter the user's name, put that on top of the scoreboard, right? Another one that's a little more complicated than that, but still quite cool, is difficulty selection. Very often in a video game, difficulty comes down to how fast is it running. So if you simply modify the speed that the animation, if you have like a tick function, some set interval in there that's controlling the physics, if you just reduce the amount of time that takes between ticks, you have increased the difficulty, and you can do that according to a slider even, right? You guys kind of get the idea with that, right? Good. Oh, all right. You want to know the other way I know that you've used ChatGPT to do the thing? If, when the game ends, it pops an alert box up. I don't know why, but the bloody AI seems to really like that one. You should never use alert boxes. Never for any reason. Never, forever, never, ever. Okay? No alert boxes. No snake, no alert boxes. Alright? Tetris is iffy, straight Tetris. Breakout is also kind of like, yeah, I've seen a lot of Breakout clones, Yes, let's see here. You're also, yes, question.
So, for example, let's say we are going to make some type of variation of Tetris.
Sure.
If you have to create like a new name for the variation, or if we just call Tetris, there's a problem with like plagiarism, or what's the
I mean, you probably shouldn't call, and nobody should call their game like the same thing as an existing game, right? I don't know. With certain games, it's kind of like the game is also a genre, Tetris is kind of like that one. Here's an example, right? Kleenex, right? Kleenex is facial tissue. most people use or a lot of people use the term Kleenex as a synonym for facial tissue, regardless as to what brand facial tissue they're using, right? So, and this has actually like been fought in courts and things. Like Kleenex is like, no, we are Kleenex, that's our name, we're trademark Kleenex. And it's like, you know, well, you can't really stop people, because it's kind of been like absorbed into the culture that facial tissue is Kleenex. So like, it's kind of become synonymous with the product category. So like, Tetris, to some degree, has become synonymous with the product category, I would say. However, it's easy enough to come up with like some kind of name, like Faketris, or Hextris, or Blocktris, you know? Like there's a million different variations you can come up with on the name, right? But yeah, so yeah, I would discourage use of like the exact name. I think that the Tetris game that comes with Linux is called Quadrapassel or something. So, thank you for your question. Any other questions? All right. So, you have to track state in some meaningful way. State means like something occurring in the game needs to feed into a variable, and that variable needs to be displayed. This could be the number of lives you have left. This could be the score you have accumulated, right? Number of balloons you've popped, right? Amount of time remaining before the game ends. All of these types of things are things which you store in a variable in JavaScript, affecting the game somehow substantially, or reporting on it, and that just has to be displayed somewhere. Preferably in the SVG itself. Okay? SVGs have a text element, by the way. You can look that up in the notes. Continue to use good HTML structure by creating header and footer around your main content. Header and footer must contain your name and a copyright notice for 2026. The page should be titled and appear neat and complete. You may use Bootstrap. You may also use CSS animations, just not to fulfill the JavaScript animation requirement. So if you want like the page in general to have a few additional animations that you do in CSS, knock yourself out, right? You just can't, like, according to the rubric, like, you need to do at least one animation natively in JavaScript. Make sense? Do you all feel you have a good handle on what's expected for this assignment? Are you guys going to wow me? Yeah, are you going to produce the best darned games I've ever seen? Yeah? At least as student assignments. Just so you know, if your project is sufficiently impressive, I do give bonus marks on this one. So, and sometimes quite substantial bonus marks too. Like, the guy who made Wolfenstein, I gave him like an extra 30%. So, yeah. And basically, anybody who gets over 100% on this assignment, that's also like, that's an indication from me that I think you could use this as a portfolio piece. Right? Make sense? All good? Any questions? All right. Sounds good. So, hand it in the usual way. And by the way, when you do your portfolio websites, don't put them up on CS Unix, put them up on GitHub pages. Y'all should be learning how to use Git. So, I don't actually need the notes. So, everybody get your code editors up and running. There we go. So, last time we did something a little bit complicated. This time we're going to do something a little simpler. We're going to do a balloon popping game, right? The balloon popping game is quite simple to put together. It meets most of the requirements of the assignment, and the requirements that it doesn't meet, it could be sort of, kind of coerced into meeting fairly easily. Now, I must say, any code which you get from me or is done in class or anything like that must be significantly transformed if you want to submit it as your assignment form. And I think that's fair. I'm going to make a balloon popping game. I don't want anybody, turning around and handing the same thing we did in class back in, okay? Fair enough? Alright. Let's get coding then. As Linus Torvalds once said, talk is cheap, show me the code. Script. I'm going to leave the style block off this time. So, so far so good. Hopefully I'm not shocking anyone with that. Alright, now for the JavaScript. So, the before we do anything else, it will be useful to have a reference to our SVG object. If we were having multiple SVGs within one document, we would have to, of course, refer to them individually. But because we only have the one, we can do it this way. Now, we want to add a border to the SVG so that we can see where it is on the page. Let's do that now. svg.style.border. Oh, I'm forgetting all the like particular names. Oh, you can just do it that way. Okay, cool. It just takes it that way. I thought I had to like break it into its individual components. 2 pixels, solid, black. There we go. Yeah, let's save that. That's a good idea. app.js. Very good. Now, there will be a few like values that are useful to have kicking around mathematically. One of them, well, 2 of them, are the width and the height of the SVG element. We can then, of course, apply these to the SVG object. There we go. Now, it's worth pausing here, checking to make sure our work is good. Test early, test often. Like, some of the stuff that I do in class because I'm kind of like demonstrating things, you know. This isn't one of them. This is the thing I actually do when I'm developing things. There you go, it works. I'll only allow myself to go like 3 to 6 lines of code before stopping and testing what I've done, right? That's a good interval. 3 to 6 lines of code is enough to express like one thought, typically, right? One, like a combination of statements that does something. So whenever you've like finished an operation, you should test it. All right? This works though. That's good. So let's see here. So now, wow. I feel like you guys could handle a grid system. You guys want to do a grid system? Yeah. The other, if you want an example of like the balloon popping game, there are lots of those back on the old YouTube channel. We'll accomplish similar things, but I kind of want to do something a little more like model view separation for you guys, right? So, okay. Let's do it. So there's a lot that you can do with a two-dimensional array of numbers. Back in the day, many games were fundamentally based on a two-dimensional array of numbers. Tetris certainly would be one of them, right? So, let's throw another constant in there. Grid size. Let's say that our squares are 25 pixels on a side. So, now, we need a grid, we need a data structure, we need a field of play, right? I know I'm making changes and not talking. I made a few changes to our constants up there. I think you guys will like what's about to happen. So, let's initialize our board. We're trying to make a two-dimensional array, right? Two-dimensional array is fundamentally an array of arrays. Something like that, right? Dot, 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 dot. So, the way that you construct that from scratch, you'll notice that I've initialized board as an empty array, or an empty list. The way that you construct something like this is you first construct this guy, then this guy, then this guy, right? You write a loop to construct each of the rows, and at the end of that loop, within another loop, you push all of those rows onto the larger array, which in our case would be the board, right? So, we'll need a nested loop. Anytime you're doing anything in 2 dimensions, you have normally a singly nested loop, right? So, for let's I equal 0, I is less than width divide by grid size, which is of course the number of cells. That might not be the best way to do it, but I'm doing it this way for now. There we go. Copy, paste that. Oh man, I'm gonna have to, there we go. We'll need I and J. And this one will be, actually, the outer one will be height. The inner one will be width. There we go. Let row equal empty array. have to put that here because the purpose of the inner loop is to create a new row. So we create the new row variable outside of the inner loop, but within the inner one, or within the outer loop, it's sandwiched in between. At the end of this, we want to board.push row. Push is the same thing as append in JavaScript. I think in Python they call it append. Yeah. So row.append or row.push I time I plus j mod 2. Interesting. What is he doing? Who knows? Let's run this and see what it does, shall we? What does that look like to you guys? I got 0, 1, 0, 1, 0, 1. Then the next line is 1, 0, 1, 0, 1, 0. What if zeros were white and ones were black?
Oh,
It's a checkerboard. Boom. So now that we have an underlying board, we need a function which actually takes the data structure and produces something from it, right? We need SVG elements to show. So now we get into the part of the game where we need to learn how to create an SVG element. Creating objects from JavaScript is a 3-step process. Step number 1, similar to Java, you must initialize the object. Step number 2, you must assign attributes to the object. The object will be blank when you create it. Number 3, you must bind it to the element that you want to add it to, right? You need to assign it a position within the document object model. So let's see if we can create one square. And if we can create one square, we can generalize that. So there is one extra step that's required, however, in the case of SVG. You kind of have to just go to the notes for it. So SVG is not HTML. Its definitions are not loaded by default by the browser. In order to create elements of SVG types, we have to load the definitions from a remote URL. That's what the following 2 lines of code do. So, there we go. We will want SVG-NS, which is the remote definition of SVG objects. When we wish to create a particular SVG object, That's how we do it. Make sense? So this is this line. I'll pull this up so it's all on one line for you guys. Or all in one. There you go. So, having created the square, we must now assign to it the properties that we want it to have. Just so that it shows up on a white background, I'll do this as a red and black checkerboard rather than a red and white checkerboard. You know, so square dot set attribute. There are 5 attributes we need to set to fully specify this square. Anybody care to guess what they are? X. X and Y are 2 of them. Width and height. Yeah. There's one more.
Column?
Not column. The center points are for circles, not rectangles. X and Y will register to the top left corner. So in a rectangle, that point right there is X and Y. You then have height and you have width. Because we're doing squares, width and height will be the same as grid size. Right? Color. Color is, and it's fill. Fill is the fill color for the square. Right? If somebody said that, I apologize. I didn't hear you. So, we need X, we need Y, we need width, we need height, we need fill. So, width and height are easy. Those are just the grid size. Right? X and Y are slightly complicated, not very complicated. So, what we have to understand is the mapping between physical space in the SVG and our array model, right? So, in our array model, right, we have 0, 1, 0, 1, right? We want to draw these in the grid. Oh man. Can he repeatedly, evenly bisect a square? That's the question. Did he draw it as square to begin with? That's the other question. There we go. So, this 0 corresponds to this square. If we are having i's going this way, 0, 1, 2, 3, 4, and if we have j's going this way, 0, 1, 2, 3, 4, etc., etc., we have to think about where the registration points are for these squares. They are always in the top left-hand corner. This one will be 0, 0, easy enough. This one will be 0, 50, 0. This one will be 100, 0. This one will be 0, 50. This one will be 50, 50. This will be 50, 100. Anybody see a pattern? What is it?
It's I times 25 or j times 25, which would be the grid size.
Yes.
Or 50 in this case.
Yeah. It's literally just x is I, j is y, multiplied by the grid size. Nice and easy. Nice and easy. Of course, in our case, we don't have I and j yet because we haven't put the loops in. So let's just hard code those as zeros for now. Let's hard code this as red for now as well. Now we must take the square and add it to the SVG element. We have a convenient method for doing so. Square dot, SVG dot add, not add, append child square. One of the things that I love, absolutely love, about JavaScript is how the methods are consistently named. They're not consistently named. In one case it's called push, in the other case it's called append. JavaScript can't make up its mind. That's JavaScript. JavaScript hates you. So, let's see if that works. Oh no. Wait. Oh yeah! We just have to call the function. Very good. So, now we need to generalize this so that we stick that inside of a couple of loops, have it work on I and j as given previously. In the interests of keeping things moving, I'll just show you how to do that. So these guys here, you can literally just copy paste them in. By the way, if you highlight a bunch of rows and you press tab, you can tab over a whole lot of rows at once. Shift tab allows you to remove indentation. Very handy. That probably also works in VS Code, which most of you are possibly using. How many people are using VS Code? How many people are using Notepad++? How many people are using something else? Interesting. Okay. The main reason I don't use, I'm not using VS Code is that it tends to crash in the middle of long lessons. But when the rewrite for this course that I'm working on, basically endorses WebStorm as the official IDE. WebStorm's made by the same people who make IntelliJ. So, now that we have I and j here, I times grid size, j times grid size. There we go. If we run this now, well, it's all red, which is okay. As soon as we modify the fill, it'll get interesting. Or even switch on board at I at j. case 0, break, case 1, oop, break, and it's often useful to put a default in here. We'll do typical, like, missing texture purple. Looking good? Ooh! Now that looks pretty spiffy, doesn't it? Now I've gone with a very classical 8x8, 64 square checkerboard, but of course you can, through modifying these values, come up with a checkerboard of any size you like. Because of the way we've designed it. Interesting, right? I think that's it. It would also be possible to, like, hold constant how many squares of width and height you want and then calculate these values from that based on the grid size, but, you know, 6 to 1, half a dozen to the other. So, how many people have gotten that working? How many people would like a little more time? Alright. Yes.
Just a quick question on the width and height of the SGV elements.
Mm-hmm.
I have it pretty much copied vertically right here. And I've also done it through. But when I go to limits, so out of the element or the ID in place of it, but the width doesn't correspond to the
Yeah, that's default SVG size. Can I just comment that out?
Yeah, sure.
Is it being? No. Control S. Oh, yeah.
Everything else seems to work fine. It's just not 600 by 600.
Huh. So that is the thing I commented out. Grid. It's not applying it.
But it wants to apply the border.
Yeah, it's applying the border, but it's not applying with the height, which is strange. did you put, ooh, something like that maybe?
Yeah, I can try that.
Yeah, I can't see the difference.
That works.
That worked?
Yep.
Ah, weird.
That's annoying.
Weird.
Ah.
Yes.
Can you put the HTML on screen real quick?
Sure.
Oh.
Still quite simple.
Well, I don't think that get rid of
Anybody need me to take a look at anything? Okay. Yes.
No, I know. That's supposed to be the same. This, here, take every piece to the. No, every piece.
You're writing a CSS property. The default value is for it to interpret it as pixels, but if you like typically with CSS properties, you put the unit in there, right? So that's what we're doing. We're putting the unit in. So. Can you open up the browser?
It was zeros.
Live server. Not.
That's the whole point about this, like, it's like, you don't have to call it a yeah, that's just, obviously, that's just an extra position of all that. It's your function, everything knows this. For some reason, it's not all your functions. It's the same function.
We should do
Seems to be. I'll have to look closer here. Wait, what's this?
Why'd you think about it?
That's the problem right there.
That's probably why.
Yeah, that's the problem. All right. Autocomplete is not always your friend. Ask anybody with an iPhone. Okay. So, actually, I kind of feel like we should have the break now. It's about the middle of class. Any objections? All right, let it be so then. We shall have a 15-minute break. Please be ready to resume class at 10:41. Yes. Code for me to look at? You do. You mind if I just whip off to the little mad scientist's room first? Since this seems to be the direction we're going, fairly simple. Now, let's add pieces. Let's add pieces. We can add pieces in a very similar way to how we added the board, right? Let's make a new array. Let pieces equal a new array. we can in fact copy paste this code, initialize pieces, there we go. Now, we're going to assume, make some assumptions that the board is 8 by 8 at this point. So, what we want to do is we want to complicate this middle bit, right? So, let's decide 0 means no piece, 1 means, normally like with checkerboard you'd have like red and black pieces on a red and black board, but that's not going to show up very well. So let's do like white and blue pieces, right? But either way, 0 will be no piece, 1 will be white, 2 will be blue. Okay? So, we only want to add a piece if this comes out to the same thing, right? In checkers, you always play only on one color of the board, right? Otherwise, we're pushing a 0. Row dot push 0. So now, basically we have to write a fairly simple if statement. If we're inside of the first 3 rows, we're assigning a 1. If we're in the last 3 rows, we're assigning a 2, and if we're in the middle, we're assigning a 0. Right? This is another if statement. If I is less than or equal to 2, row dot push 1, else if I is greater than or equal to, I don't know, 8, 7, 6, 6, minus 1 because it's an index, 5, row dot push 2, else row dot push 0. So we want to push those onto pieces, not board, because we're modifying the pieces array. Sound good? Let's check our work. Pieces, show me the pieces. That looks like that worked. We're going to be playing on black, it seems, which is fine. Probably according to the official rules of checkers, there's like one of the colors you're supposed to play on, but who cares? It's kind of like in chess where like it doesn't actually matter if the queen's on black or the queen's on white, as long as you're both on the same thing, you're basically just playing a mirror image game, which doesn't actually affect the logic, right? But there's lots of stuff that people think matters that doesn't actually matter. There's another piece of life advice for you today. There's a lot of things that people think matter, and they don't actually matter. Alright, now we need to draw. So this is the part where we are drawing the board. We also need a part where we are drawing the piece. Drawing the piece will be very similar to drawing the board. We won't be drawing a rectangle though, we'll be drawing a circle. Circles have three attributes which control their geometry. Center x, center y, and radius. For the time being, let's just copy these over. Center x, center y, and radius. Let's leave it like that just for now. We should probably piece, there we go. We can copy this bit over. There we go. So 1 was white, 2 was blue, and we'll leave default as purple. Then of course, we need to append this item like so. Let's see what we get. Uh-oh. Well, that's buggish. That looks a bit buggish, doesn't it? So, well, here's an issue right there. %90 of bugs are caused by people copy-pasting code and not copying stuff over. So this is not what we're looking for, right? I made another error. Pieces. Right? We're not drawing the board, we're drawing pieces. Oh. Well, progress. The purple shouldn't be drawn though. So we shouldn't draw a piece if this segment, if this region in the pieces array is 0, right? So the reason I'm showing you this, right, the reason I'm doing it this way is to kind of show you we have the initial approach, we just have to refine it, right? So, if pieces at ij are not equal to 0, do all of this. Somehow we've managed to destroy the board. I think that's because I cut instead of copied that. There we go. All right. Okay. This is beginning to look better. The radius is too big, right? The radius should at most be half the size of the grid. You know, confusing radius for diameter. But maybe we might even want to make it a little bit smaller than the grid, so the grid can be seen. Ah! That's beginning to look correct. Alright. Now we just have to do something about that offset. Right? This is the difference between a circle and a square. Squares have their registration point at the top left. Circles have their registration point in the center. So, in order to put this thing in the middle of a square, we need to offset center x and center y by half the size of the square. Plus grid size divided by 2. Oh, look at that. We only have one issue.
They are on the same color.
Sorry?
They are on the same color? The same square color?
No, normally checkers is like top and bottom, and this is side and side.
Oh.
For that, we can go back to the point at which we initialized the pieces. And if we simply exchange I for j here, ta-da! I don't think that blue shows up very well on that black. So I'm going to change it to light blue. But now that looks too close to the white.
Put yellow.
Yeah, that'll work. Yeah. So there we go. Okay. Very good. So far, so good.
Can I see the code?
Certainly. Which piece of the code?
Can you scroll up to the initialize pieces?
Mm-hmm. So, the thing that we now, like the next logical thing to do here is to be able to move a piece, right? So, we want to be able to click on a piece and then click on a square or another piece and have the piece move from that position to the other position and then redraw the board, right? So, we'll need to keep two pieces of information in memory. Gesundheit. We'll need a from x and y, right? And we'll need to hold that if the user has clicked on a piece, right? So let's move from x equal -1. -1 often is like a good, like this is an well, I guess we also have undefined as well, that would work fine. There we go. Let moving equal false. Now, when we create a piece, we also want to give it a click event. Piece.add event listener. Click. Function. There we go. Now, basically what we want to do when we click on this thing, two things. Probably we want to have the piece we've clicked highlighted in some way. This will show that the piece is selected for moving, right? And then, like giving it an outline would be perfect. And then we want to register its current location. That location will be used by the next event that tells it where we're going to send it. Alright? So, style, or this dot style dot border is equal to, say, 2 pixels solid blue. Move from x is equal to okay, I'm going to have to do something a little bit strange. So this is kind of like an object-oriented kind of, I don't think this works in strict mode, but so in JavaScript, you can add new attributes to an object at any time. Here, I'm taking our newly created piece, and I am storing inside of it, oh, I. That should be I and J. There we go. I'll call it board I and board J. There we go. Minimize confusion. So I'm storing the information about where this thing is located in the board in the object itself. That way I can pull it out later during the click event. So move from x is equal to this dot board. In fact, let's just, there we go. Move from y is equal to this dot board j. Moving equals true. Now, we should only be able to do all of this, right? All of this code should only work if we are not currently moving a piece. Right? So if not moving all of that. Right? So we can take this and test it. Let's do so. Ah, come on. Let's just make sure that we're even getting inside the event. We are. So moving, if not moving, so if moving is false. Give me the value of moving then. It's false. Bloody JavaScript. I hate you, JavaScript. Or maybe I just hate logic. Ah, so we do get in there. Alright. So then the question is, what's this? It is the circle. Okay. Oh wait, I'm using CSS ways of doing this. I should be using other ways of doing that. This dot set attribute stroke blue. Let's try that. Oh, it worked, but it's very, very hard to make out. So let's make it purple. And maybe to all of these we set piece.set attribute line width. Where's line width as an SVG property? What's it called? Stroke attributes. Stroke width. Okay, it's called stroke width. Thank you, W3 schools. Stroke width. Let's make that a nice chunky 4 pixels, shall we? Uh-oh. Unexpected number. 970. Stroke width. Oh. Comma, not period. Book. I still don't like that color though. What's a good color? Orange? Actually, orange looks pretty good. Orange shows up pretty well. There we go. So, all right. Now, we can click on and highlight something. Move from X, move from Y are given. All right. So far, so good. Now we have to do the complement event, right? The event that picks up the information that this one laid down, right? Incidentally, there's a whole host of events for drag events as well, which, you know, you could also do a game like this using drag events pretty effectively, right? But for now, let's just keep it simple and do clicks. You guys like how I'm keeping this lesson simple, right? Right. So let's turn our attention to a space on the board. Square.add event listener. Click. function, etc., etc. Now, moving to a square only works if we are moving. If we are moving. Now, what we want to do, we want to edit the pieces array, right? So, but we should also store this information here as well. That'll be useful. Square, board I, board 2, there we go. So, pieces at square dot board I square dot board j is equal to pieces at move from x, move from y. We are moving whatever the value is of the thing we clicked on into whatever we just clicked on the board. We also want to take this position and write 0 to it to clear that space on the board. And thus, with all of this accomplished, we should be able to move an item. There we go. Let's take a look at pieces. Well, one was moved. Did I, oh, yes, okay. I made a mistake. We also turn ourselves out of moving mode when we've accomplished that. 1, 2, let's take a look at pieces. I think I just clicked multiple times and that screwed it up. Yeah, see? If you take a look right here, we've moved our value from this spot to that spot. Very good. Now, the problem we have, we need that to show up on the board. Right? So, let's return to our draw board method. Or, before we do that, let's use a method we haven't yet written, redraw. Whenever we actually move something, we should redraw the board. Right? So, down we go, redraw. Let's write a, well, let's put that up by draw, that makes sense. Yeah. So, redrawing the board is comprised of 2 operations. First, we have to delete everything in the board. Second, we redraw everything, we draw the board like we did the first time. So the second part is we just call the draw board function again. And I know what you're going to say, but Mr. Professor, sir, literally only one piece has changed. Why are we deleting the entire board and redrawing it? Couldn't we just delete just one piece? And the answer is yes, we could do that, but this makes the program simpler, right? So we'll do it the simple way, and if you want to optimize it to not delete things that don't need to be deleted, I will leave that as an exercise to the reader. So, whatever we do, afterwards we will have to redraw the board. So, this is what we need to do. We need to gather all of the children of the SVG and delete them. Now, there are a couple of approaches you can use to do this. We could use our regular mechanisms. Use a query selector, right? Query selector all, grab all rectangles, grab all circles, and delete them. But if our object is to delete everything in the SVG period, there's a simpler way of doing that. There is an array that contains all of the children of the SVG. And it is just svg.children. There you go. That is a list of references to every element on the board. So, the thing we have to do now is loop through and destroy them. Let children equal, well, yeah, svg.children. I'm doing this mostly for superstitious purposes. It's often a bad idea to loop over a data structure that you're currently modifying, right? Like, here's the question, right? If I have an array of things, right, and I'm going through and sequentially deleting every single one of them, if I delete this one that was at index 0, right? If all of the elements of the array shift up, and at the same time I've increased my index, I will only be deleting every other element, right? Because the array will be shifting up at the same time I'm shifting down through it, right? So, you know, you can write this in a way that's kind of agnostic as to how lists and deletion are being handled by simply duplicating the array and going through it that way. At least, I'm not sure if that actually creates a full copy. Maybe I'm just being superstitious, but yeah. Well, I suppose we could loop through it, assuming that we're always deleting child 0. Yeah, and you guys don't see while loops often enough. So here we go. While svg.children.length is greater than 0. While svg has still remaining even a single child, delete the child. This is how you do it. To remove an object from another object, you need a reference to both of them. the removeChild method is called on the parent object. The parameter passed is a reference to the child you wish to delete. It is necessary to do it this way because, as we see with the SVG, nodes often have multiple children and you need to be able to directly say which one you're deleting. So, let's try it out, shall we? So, I'm going to call the redraw method. If it works, we should have the same number of elements as we had before. So let's take a look at svg.children. You can see we have 88 children. Redraw. SVG has 88 children. Okay. Seems like we might be doing something here. Now, click, click. It works! But of course, this is the worst game of checkers imaginable. Right? We can move into the red squares, right? But, clicking on an opposing piece doesn't move us to that square, but clicking on the square around it does. So basically, the circle is blocking the click event for the square underneath. Right? Easy enough to fix. If we go in here, this bit here, if we copy that, create an else case down here for it, it will have to be modified very slightly from square.board to this.board. And in fact, should probably have it as this up here as well. We can click directly on the checkers. Make sense? Any questions? All that remains now to get a functional game of checkers is to write the rules according to which pieces move. Yes?
So just two questions. So back on the Windows where we have the checkboard. So for example, if right now we refresh it, they would just all reset to the original position. If we refresh
So
the window.
the redraw method will not appear to do anything, right? So unless I go in and I manually modify the state of the pieces. So if I go in for pieces 0, 0, right? Pieces 0, 0. That's currently 0, right? If I set that to a 2, right? And then I redraw the board. Zero, 0 now has a 2 in it, right? Does that make sense? Does that answer your question? Yes. Any other questions? Yes.
Why, when you double click a piece, it vanishes?
Boom. So let's take a look at the code. So when a piece clicks itself, it vanishes. This is a bug. We love bugs. Bugs help us explore how the program actually works, right? So on the first click, we set the values of move from x and move from y, let's say to like 5 and 5, right? On our next run, also moving is true. On our next run, if we click the same piece, right? Pieces at this dot board I, this dot board j is equal to pieces dot move from x, move from y. So if we substitute the values in, we're saying pieces at 5, 5 is equal to pieces at 5, 5. So we're assigning a value to itself, right? Critically though, look at the next line. Pieces at these two coordinates is equal to 0. So the very next line is pieces at 5, 5 is equal to 0. We clear that spot on the board. So that's why. Now, we could fix this in two ways. We could reorder the like what we're doing here. Kind of make this into a more traditional swap operation, right? Or we could simply put an if statement in that refuses to move if the thing you're trying to move it to is the same spot on the board. Right? Which of the two of those do you prefer?
The if one?
Sure. So, if this dot board I does not equal move from x, and this dot board j does not equal move from y, do all this. So we are disabling the ability to move a piece into the same square it already occupies. One, 2, 3.
Perfect, thank you.
You're very welcome. Here's something fun. Asymmetrical checkers. Yes.
What I wanted to ask was that when doing with the board, I've noticed that like when you click on a piece, you can't pick another piece. It stays on that piece unless, and if you try to click another piece, it'll just disappear. That's the piece.
So that's something we can easily add as well. We just put an if statement in that disables something if you click the same piece. We can add an else branch to that which deselects the piece fairly easily. Else, basically you just want to undo all of this. I said? Now, click a piece, you can move it, click it again, it deselects it, and then you can click something else and move it. There we go. Pretty cool, eh? So, you guys want to do a little bit of like implementing the actual rules? You guys interested in that? Yeah? Okay. So, first things first, basic movement, right? Jumping is a little bit, like the logic for jumping gets a little bit complicated, particularly because like in checkers, if you jump, you can continue and do more jumps, right? But like the first jump has to be forward, but subsequent jumps can be backward. Like the logic for jumping gets a little bit complicated, but we can crack off basic movement fairly easily. So basically, basic movement, if you're a 2, these are your valid moves, unless there's another 2 there, or unless like you can't move off the board, right? Those are your basic moves, right? And 1, it's the same but opposite. So, for me, probably the best way to approach this is to create a function which returns the valid moves for a particular piece. Makes sense, right? So, function valid moves. There we go. We could even do this as an array of objects. Let moves equal an empty array. We'll fill it with objects. So, we'll need to know the x and y position of the piece that you're moving. And the rules are going to change depending on whether that's a 1, a 0, or a 2, right? Switch pieces at x, y. Case 0, which is a blank square, return moves. Break. Actually, technically the break, if it's a return statement, the break is unnecessary because you'll never hit it. Case 1, case 2. White, yellow. So, if you're a 1, your valid moves are your index plus or minus, your x index plus or minus 1, and your y index plus 1. Right? So So moves dot append, or dot push. We'll just do the basic version with no like bounds checking or checking for the positions of other things first. Right? Start simple, build it up. Right? This is a new syntax for you guys, I think. So, if we're doing this one, we're subtracting 1 from x, so x minus 1, j must be y plus 1. So this creates an object. Let me show you what this does. Oh, let me just substitute some stuff in here. Let's say we had 3 and 4. So x is an object then, containing values. It works fairly similarly to an object in Java. Like you can access individual elements from it using dot syntax. X.I, X.J, just like that. These things are very, very useful. So, push that move, then push this move, change that to a plus, there we go. Return moves. Now, when we click on a thing, display valid moves. Let moves equal valid moves given this dot board I, this dot board j. Right? Feed the position of the thing we just clicked on into valid moves to calculate it. Then, take whatever it gives you, find those squares on the board, and highlight them. That's actually a little trickier than you might think. Well, all right. For the time being, let's just put a little, what I wanted to do is I wanted to put a border around the square, but I don't, I need a reference to those particular squares, which means I need to construct a 2-dimensional array of the references to the squares, which is possible, but more work. What I'm gonna do is I'm just gonna draw a dot in the middle of the square that you can move to, which gets the point across. So we can grab this. For let, have I used I and j? Yes, I have. Let k equal 0, k is less than moves dot length, k plus plus. Part of the reason I'm doing all of this is because I just want to show you guys what like a real program looks like. You know, like we do so many of these like tight little constrained examples in class. I wanted to show you something with a little more meat on the bones, you know. Let's call this dot. There we go. We don't have to worry about this. And we don't want I. What we want is moves at k dot I. Moves at k dot j. We want radius to be fairly small, maybe 5 pixels. Do we need a stroke width? No. We need a fill color though. Let's use purple. Or actually orange would be best because that's the highlight color. Orange, there we go. Change this to dot. And of course, don't forget to add it to the SVG. There we go. Let's try it out. Ah, well, close. I've got my logic backwards. This would be minus and minus. But for I, they would be, or for 1, they would be plus and plus. Boop. Boop. And as long as you don't click on that little dot, it works. Because we didn't bind the dot with a click event, right? Which we could, but, you know, so it goes. But there you go. Now, the second trick, right? A couple of tricks now. One of those is not a valid move. The other one is. So we can constrain it. If pieces at x minus 1, y minus 1 is not equal to 2, we push it. Same up here. There we go. Going back here. Now if we select this guy, we can move him. If we select this guy, haha, you see, we have the dot here but not there. And if we select someone back here, nothing. There we go. To enforce this as a rule, you'd have to put something in the second half, right? The second event listener that's listening for where you want to move it to. You'd have to put something in there that would say no if the square that you were trying to move to wasn't in the list. And you would need to save the list of the moves that are valid, right? But yeah. The other one, of course, though, is like, you know, anytime we click anything on the edge, we're getting an error, right? So we shouldn't do that. And that's easy enough as well. If x minus 1 is greater than 0, greater than or equal to 0, and y minus 1 is greater than or equal to 0, and that, right? You just add these conditions in there. Little bit of simple bounds checking. You don't have to worry about them moving backwards, so you don't have to check the lower bound, right? This one moves fine. This one, oh, still a problem, eh? That one works though. There must be some bug there. Cannot read properties of undefined. Reading 3. Well, anyway, you can kind of see where this is going, right? Other things that so in terms of rules, right? We have a general system that will do a lot of different things, right? Like this system, before we sort of did that part and started constraining the piece to move like checkers pieces, this system could easily do chess, right? It could easily do any of these sort of board games that are like based on a checkerboard, right? It's by constraining the ways that the pieces move that you create the rules for the game, right? Another constraint that you would put on the pieces is you move, then I move, right? You would have to keep track of whose turn it is. Only white is allowed to move on white's turn, only yellow is allowed to move on yellow's turn. Make sense? So you can see how you can kind of build off this base, right? But yeah, I don't know. I think we're done. Any questions? And don't worry, I will publish the code. Yeah, okay. That's it for me then, folks. Thank you very much for your time and attention. And we shall continue this next week.
Thank you.